Hello, hello, hello. Welcome to paper one for Edexcel's higher tier GCSE maths walkthrough. So this is paper one in 2023. So this is when we had some pre-release material. Things may have changed depending on when you're watching this video. I do believe this is a fair paper, more or less. There's a few horrible questions, but that's just the nature of GCSE at the last few, of course. Anyway, let's have a look together at question number one as I talk you through step by step how to do these questions. Question 1. Work out 8.46 divided by 0.15. So, fairly tough first question. What I would suggest is, if we have a decimal division to do, to think of it as a fraction. So first of all, one number divided by another could always be considered as a fraction. So it's always the first number, then over what you're dividing it by. So that'd be my first step. Now, to be honest, dividing by a decimal I think is quite difficult, and also fractions and decimals rarely mix. So what I'm going to suggest we do here is to make the denominator into a whole number. The best and easiest way of doing that is usually just to multiply top and bottom of a fraction by 100. So if I multiply top by 100 and the bottom by 100, this will then convert this fraction into its equivalent, 846 over 15. So now we have this. What we can do is see if we can do this division. So basically, how many 15s go into 846? By the way, this does simplify if you can spot that, but I'm going to assume if you can't, we can just do this division straight away. So 15 into 846. Because it may be a few decimals after, I'm just going to put a decimal point, then a few zeros if needed, because I'm not sure at this stage if we're going to have a decimal point and it's going to be a decimal answer. Well, let's assume that you might not know that. So first of all, does 15 fit into 8? It doesn't, of course. And so the remainder here, because I've not used any of that 8 moves on. Then 15's into 84, count them up. 15, 30, 45, 60, 75. There's not room for one more, so I can fit 5 15s into 84. 5 15s is 75. How far away from 75 is 84? It's, of course, 9 away. And so, therefore, the remainder for this next one is going to be 9. Then we think, how many times does 15 fit into 96? So if I carry on this 15 times table counting upwards, 15, 30, 45, 60, 75, 90 would be the next one, which is 6 15s. There's obviously not space for a 7th, therefore I can fit 6 inside. Then how far away from 96 is 90? Well, 96 take 90 is 6, so the remainder now is 6. So that 6 carries on past the decimal point, and make sure the decimal lines up on the top and the bottom. Finally, how many 15s go into 60? Well, that's going to be 4 and 4 exactly. So therefore, because it's 4 exactly, we can stop the division, and we have our answer. So therefore, we have 56.4. So that's question 1 dusted off. We've got our marks in the bag, so let's get some more by tackling and succeeding at question 2. Question 2, mixed number arithmetic. We need to work out 7 3/8, subtract 2 1/2. And we're told to give our answer as a mixed number. So the first thing we need to do here is to convert both of these fractions into top-heavy fractions. And to do that, we do the whole bit multiplied by the denominator, and then add on the numerator. So first of all, for this fraction, 7 multiplied by 8 is 56, then add on the 3 is 59. So for the first step, the first fraction becomes 59 over 8, minus, so stick a minus sign in, and this one, converting to a mixed number in the same way, 2 multiplied by 2 is 4, add the 1 gives us 5. So that becomes 5 over 2. Now, if we're doing one fraction multiplied by another, it's important to have the denominators the same. There's a few ways of doing this, but here we can spot, hopefully, that 2 is a factor of 8. Therefore, I can easily convert 2 into 8 by multiplying it by 4. But if I do that to the denominator, I have to do the same to the numerator. So multiply top and bottom of 5 over 2 by 4 to keep it equivalent. That gives me 59 over 8 minus 20 over 8. The denominators are now the same, so I just subtract the numerators for top numbers. 59 take away 20 is 39. I need my answer as a mixed number. My final step, therefore, is to see how many 8s fit into 39. I can fit 4 8s into 39 because 4 times 8 is 32, but 32 is still 7 away from 39. So I have 7 8ths left over. So the answer for that one is 4 and 7 8ths. Question 3. A cube has a total surface area of 150 centimeters squared. Work out the volume of the cube. So, total surface area 150 cm squared. That's our main way into this question. So, need to remember a cube has 6 faces. So that's an important point. Obvious, but you need to remember it. So let's think about how that can help us. That means that 6 faces in total add up to 150 square centimeters in area. So, therefore, dividing by 6, each single face must be 150 divided by 6, which gives us 25 square centimeters. If we now consider a sketch of a cube, you don't have to, but I'd suggest it might make it easier, then we can picture it like this. So if each face is 25 square centimeters, that tells us, because each face of a cube is a square, each side of it must be 5, so that 5 times 5 gives us the 25, which we know we need. The total surface area of a cube is the area of each face combined, so that is 25 times 6, which works. But because we need the volume, to work out the volume of a cube, it's the length multiplied by the width multiplied by the height. Or put even easier, it's just the length of it cubed, hence the name cubed. So all we need to do now is 5 cubed, or 5 times 5 times 5, to give us a volume of 125 cubic centimeters. Question 4. We have a table showing information about the daily rainfall in a particular town for 60 days of the year. We now need to draw a frequency polygon for this information. So the keyword frequency polygon, how do we do that? Well, when we make a frequency polygon, the key fact is that we do it from the midpoints. So we have to plot from the midpoints of these intervals. Not from the 0 for this one, or from the 5, but from the midpoint. So my suggestion would be to make an extra column on this table for the midpoints. I'm going to do it in the middle. You can do it at the end. Doesn't particularly matter. So halfway between 0 and 5, the first midpoint is 2.5. Between 5 and 10, halfway is 7.5, and so on for 12.5. This next one's 17.5, and finally, the final midpoint is 22.5. We now plot along the midpoints and up for the frequency. So our first point is 2.5 along and 8 up, then 7.5 along, 24 up, and so on and so on. So our 1, 2, 3, 4, 5 plotted points should look like this. And our final step to complete our frequency polygon is just to join one point to each next point with a straight line using a ruler. So we end up with something like this for our final answer. So that's our fully completed and constructed frequency polygon. Question 5 is about a Venn diagram. This curly E means everything inside the Venn diagram. So all the items inside the Venn diagram are the numbers from 1 to 10 inclusive. So A is the odd numbers and B is the set of all the square numbers in this list. We need to complete this Venn diagram for the information. So odd numbers. The odd numbers in this list, I'm going to underline these in red. 1, 3, 5, 7 and 9. Square numbers I'll underline as well in blue. So first of all, the odd numbers, 1, 3, 5, 7 and 9. Square numbers, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So in blue, I'm going to underline 1, 4 and 9. So you can notice here that there are 2 numbers that are both odd and square. Those numbers are the 1 and the 9. So if A is just the odd numbers and B is the square numbers, in the middle, in the overlap, technically called the intersection of A and B, will be the numbers that are both odd and square. So because 1 and 9 are the only numbers of these 10 that are odd and square, we fill in the middle first always, by the way. So we just put 1 and 9 in the middle because only 1 and 9 are both odd and square. Next, I'm going to fill in the numbers that just happen to be odds, but not squares. So that's number 3, 5 and 7, which go here. And in B, just B this section, we put the numbers that are just square numbers but not odds. That's just going to be the number 4. But because in our Venn diagram needs to live everything, the entire universal set, we've not included all the numbers of the universal set here yet. We're still missing 2, 6, 8 and 10, but 2, 6, 8 and 10 are neither odd nor square. They still deserve to be in the Venn diagram, but because they're not in set A or B, they have to live on the outside of the circles, but inside of a rectangle. So around the edge, in any order, we need to put 2, 6, 8 and 10. Something like this would do. So 2, 6, 8 and 10 in green, underlined here. Going to add in like so. Now for part B, it says a number's chosen at random from the universal set curly E. So if a number's chosen at random, it could be any one of these 10 numbers. We need to work out the probability of this number chosen is in the set B dashed. B means set B. B dashed means not in set B. So if I just grey out set B and consider the numbers outside of set B, for numbers outside of set B, I've got 1, 2, 3, 4, 5, 6, 7 options at a total of 10 numbers. So therefore, for part B, the probability of a number being in the set B dashed is the 7 numbers I could choose from out of the total of 10 numbers altogether in the universal set. So therefore, the chance of a number being picked being in the set B dashed is simply 7/10. Question 6, we have a scatter graph showing the information about the ages and weights of some babies. Describe the relationship between the age and the weight of the babies. So as you can see, age increases along the x-axis and the weight increases along the y-axis. And surprise, surprise, as babies get older, they grow in weight as they approach infancy, then whatever, being toddlers, then children and adults. So obviously, very obviously, as age increases for babies, the weight's going to increase as they grow and get older. However, the key thing here is it's a scatter graph, and pretty much virtually for any scatter graph, I'd always suggest straight away as an knee-jerk reaction, trying to draw on a line of best fit. It can never ever hurt. So a line of best fit for these data points, we need to find a line which goes through roughly these points, and a general rule of thumb, try and aim for having half a points above the line and half a points below, but don't go out of your way to try and get a line close to points which don't fit the pattern. Something if it was like down here, which is none of these points, those points are called outliers. So the line of best fit ignores the outliers and goes through the main trend. So my version of my line of best fit is this here. Yours might be slightly different, and that's absolutely fine. But the line of best fit can help you to answer part A. So describe the relationship between the age and the weight of the babies. So as we read from left to right, you can see this line of best fit is sloping upwards. So that's saying, because the correlation is positive, basically it's saying as age increases, the weight of babies also increases. Surprise, surprise. But to get the marks, we need to state that explicitly. So in terms of a explicit statement, I'd suggest writing something along the lines of like this. Put it as simply as you can. So as age increases, the weight increases as well. So you might be able to get away with saying positive correlation, but to be absolutely sure, I'd recommend to just say, in terms of the variables, what's happening. So as one increases, the other increases or decreases. In this case, both increase as the other increases. So because we both go along the same lines, it's positive correlation. So for part B, we're told that another baby has a weight of 5.8 kilograms. This is where the line of best fit comes into its own. So a weight of 5.8 kilograms, we can then estimate, using this line of best fit, to find the estimated age of this baby. So what we're going to do is read across at 5.8, like so, until we hit the line. Then when we hit the line of best fit, we then read down from this point here to work out what the estimated age is. So reading down, for my own line of best fit, it's between 2 and 4. That's 3, 3.2, 3.4. So based off my line of best fit, I'm getting 3.4 months. Now, doing a line of best fit at GCSE is a fairly personal thing. Your line of best fit might be different to mine, and that's absolutely okay. The examiner knows there's going to be slight leeway and differences called tolerance. So as long as you've done a valid enough line of best fit, there is some wriggle room. If your answer isn't 3.4 exactly, it's okay. The examiner would accept, based off a valid line of best fit, anything in between 2.5 to 4.5 inclusive, as long as it's based off a valid line of best fit and clear method. Question 7, we're told about a price of a holiday. It's gone up by 20%. That's damn inflation for you. So anyway, this 20% increase adds £240 onto the price of what the holiday used to be. Work out the price of a holiday before the increase. I would always say to my students, before anything happens to an amount, you always start off with 100% of its original self. So here it's saying 20% increase is equivalent to £240 of the original. So therefore, the original was 100%. This bit of information here, the 20% must be equal to £240. So 20% of the original equals £240. So we start off using this bit of information like so, and then the original price is going to be 100% of itself. So how do we go from 20% to 100%? Quite obviously, I think, or fairly obviously, we can multiply both bits by 5 to find 100%. So 100% original price will be 240 multiplied by 5. 24 times 5 is 120, so 240 times 5 is going to be 1,200. So we're going to get this here. So therefore, the original price will be this £1,200. Question 8, we have a solid cylinder stood on its circular base as shown. So the cylinder in question has a volume of 1200 cubic centimetres and a height of 40. The cylinder exerts a force of 90 newtons on the floor, and we need to work out the pressure on the floor due to the cylinder. So the volume's 1200 and it's clearly a cylinder, so how would you work out the volume of a cylinder? What we need to recall is the following. The volume of a cylinder is the area of its circular end multiplied by its height if it's stood up, or multiplied by the length if it's laid down. So we know the volume is 1200. The area of a circular end is just this circle here, as so. So this area there can tie into this bit of a formula here for area. As well as that, the height is a necessary component for the volume, but we're told the height is 40. So if we plug the volume and height into this formula, we can then work out the area after. So the volume, which is 1200, equals the area of the end, just call that area, multiplied by 40. We can work out the area by isolating it by dividing the right hand side by 40. But if I divide the right hand side by 40, I need to do the same to the left hand side. So therefore, this area will be 1200 divided by the 40, which is 30. I would do 12 divided by 4 first, which is 3. Cancel the zeros to get 30. So therefore, the area of this circular cylinder is 30. So we know the area now. And also, the question needs to tell us the force, and it does. So the cylinder exerts a force of 90 newtons on the floor. So we know the force is 90. We've calculated the area is 30. So therefore, the pressure exerted will be the force, which is 90, divided by the area of the surface in contact with the floor, which we know is the area of the circular end, we've worked out to be 30. Therefore, the pressure is going to be 90 divided by 30, and 9 divided by 3 is 3. Cancelling zeros, 90 divided by 30 is the same as 9 divided by 3, which of course is just 3. So the pressure is 3 newtons per square centimetre. Question 9, we have a graph with 2 different straight-lined graphs drawn on. So we need to use these graphs apparently to solve the simultaneous equations 2 minus 2y equals x and 2y equals 3x minus 22. If we look at these graphs here and the equations, 2 minus 2y equals x, that's exactly the same as this line, and 2y equals 3x minus 22 is exactly the same as this line here, which is sloping upwards. So this one here I'm going to annotate in red, and 2y equals 3x minus 22 I'm going to add in blue. So where they are both equal is where they both cross each other. So the solution to these simultaneous equations are going to be given by this point of intersection, which we're going to highlight in green. So the solution is when x equals this value here and y equals this value as I read along to the left here. So if that's 5 and that's 10, the solution is going to be when x equals 6 and when y is 2 units and also 2 squares down when y is minus 2. So the solution to these simultaneous equations is x is 6 and y is minus 2. Question 10, we have a pentagon. Irregular, of course, because it's very wonky looking. So importantly, this bit of information here, we say the angle AED is 4 times the angle of ABC. AED, this middle angle, is this one here, and ABC, this middle angle, is this one over here. So this one here is 4 times bigger than that angle, but we're not told what each angle is. So I'd suggest we just call one of them x. So if AED, this one, is 4 times bigger than this one, just add in some colour, like so. The best thing to do is to call the unknown x. So call the smaller one x. If this one's x and AED is 4 times bigger, then if I call this one x, or just any letter to denote an unknown, this one will be 4 times that letter. I'm going to call this one x. 4 times x will be 4x for E. Now, a pentagon. What we could do with knowing, really, is the sum of all the angles inside a pentagon. Now, for any shape, you can always think of any shape as a number of triangles glued together. So, how many triangles would make a pentagon if they were to glue together? So, picking any point and doing triangles coming off from that point, if I put this point here at D, let's go for D, then I can see here that the whole pentagon consists of 3 triangles. The angles inside each triangle is 180 degrees. So if that's 180, this one's 180, and that one's 180, therefore 180 multiplied by 3 is 540, which is telling us the sum of all the angles inside any pentagon adds up to 540 degrees. So x and 4x plus 120 plus 135 plus 110, all these angles here, I'm going to colour code nicely, must add up to 540 degrees. Like I said, I did promise some colour coding, so I've got a very nice yellow, an aquatic blue, a green, a purple and a pink. Add up all these, they need to add up to 540. So we can formulate an equation from this to solve for x. And x is going to be ABC. We're then going to multiply that by 4 to find AED. So putting this into an equation, we've got 120 plus 4x plus 135 plus 110 plus x is 540. So let's simplify this. 4x plus x gives us in total 5x. 120 plus 135 plus 110. If in doubt, do it using column addition. You might be tempted to rush with an exam, but you're actually better to not rush and take your time and get the marks you can do, rather than putting undue pressure on yourself and trying to do everything and then therefore actually making mistakes on the questions you're very good at naturally. So take your time and get the marks in. 0 plus 5 plus 0 is 5. 2 plus 3 is 5. Plus the next one is 6. 1 plus 1 plus 1 is 3. So clearly I've got 365 degrees here. So therefore these numbers on their own total 365. So 5x plus 365 equals 540. I then need to have these 5x's on their own, so I can subtract 365 from both sides of this equation. And I'll show you how to do that as well if you're not too confident with subtraction. It's absolutely fine if you're not. I'll show you how to do it. So 540 minus 365. I can't do 0 take away 5, so I can borrow 1 from this 4. So borrowing from the 4 becomes 3. With 1 I've borrowed, I'm going to move 1 to the right. So this is 0 now becomes 10. 10 take 5 is 5. Next, 3 take away 6 I can't do, so I need to go next door to borrow 1. That 5 becomes 4. 1 I've borrowed, I'll put next door to the 3, which now becomes 1, 3, 13. 13 take away 6 is now 7. Finally, 4 take away 3 is 1. So what it's saying here is that 5x must equal 175. So therefore, 1x will be 175 divided by 5. Again, if you're not sure, let's do it together. 5 into 1 doesn't go, so that 1 is still unused. The remainder is 1. This 7 now becomes 17. 5 into 17, I can fit 3 5s into 17. 3 times 5 is 15. I still have 2 left over because 15 is 2 away from 17. Finally, 5 into 25 goes 5. No remainder, so we're done. So therefore, x, this one here, equals 35 degrees. Very commonly, you might think, oh, I'm done, I found x, but actually here, I need to work out the size of AED. AED is 4x, so what I need to do now, finally, is to multiply by 4. So therefore, AED, which of course is 4x, that's going to be 4 multiplied by 35. To multiply by 4, I always think of it as doubling and then doubling again. So if I double 35, I get 70. Double again, I get 140. Therefore, angle AED is going to be 140 degrees. Question 11, we need to write this very awkward looking fraction in the form ax to the power b, y to the power c, where a, b and c are all integers. The best way to do this is piece by piece. So if you concentrate on the top of a fraction first, the numerator, you can see here it's all being squared. This means every single element inside is being multiplied by itself. So 6 squared, 6 multiplied by 6 is 36. X to the 5 squared means x times x times x times x times x times x times another x times x times x times x times x, which of course is x to the power 10. The quick rule is, if you have a power next to a power, you multiply the powers together. 5 times 2 is 10. In the same way, cubed, squared, 3 times 2 gives y to the 6. On the bottom, we can simplify in a similar way. We have 3 multiplied by 4, which is 12. X times x here, multiplied by another x. X times x multiplied by another x is x cubed. And finally, y to the 7 multiplied by y to the minus 3, we still add the powers. So 7 plus minus 3 is the same as 7 minus 3, which is 4. So we have y to the power 4. We'll then take each thing in turn. So the normal numbers first of all. 36 divided by 12 is 3. X to the 10 divided by x to the power 3 becomes x to the 10 minus 3. 10 take 3 is 7, so we have x to the power 7. Then finally, y to the 6 divided by y to the 4 is the same as y to the power 6 minus 4. 6 minus 4 is 2, so we have y squared. So that's our final answer, 3x to the 7, y squared. Question 12, Martha plays a game twice. So we have a tree diagram here, and the probability tree diagram shows the probabilities that Martha will win or lose each game. So we have here this diagram, and we need to find the probability that Martha will lose at least one game. So how many ways can this be done if she loses at least one game? There's actually 3 ways that could happen. She could win both, win and win, or she could win and lose, or she could lose and then win. So this could happen in 3 different ways. And so it could be win-lose, or lose-win, or lose and lose. So this here, the chance of winning and then losing and then winning, or losing and losing again, we just multiply the probabilities, we go along as we move past each branch. So win-lose, I'm going to highlight in yellow, lose-win in green, and 2 losses in blue. So win-lose will be this yellow branch here, lose-win, I'm going to put in green, and lose-lose in blue. Like this. So to work out each individual probability, we multiply the numbers we pass along as we go from the start through to the end of each branch. So for win and then lose, it's 5/8 multiplied by 7/9. Lose and then win will be 3/8 multiplied by 2/9, and then lose and lose again will be 3/8 multiplied by 7/9, like so. all we have to do now is to actually compute these fractions. So if we're multiplying two fractions together, we multiply the bottoms together. So each case is going to be 8 times 9, which is 72. And we work out the tops in the same way, just top times top. So 5 times 7 is 35. This next one, 3 times 2 is 6. 8 times 9 is, of course, still 72. And the final one, 3 times 7 is 21. So we have 21 over 72. So then if we finally add all these together, that's 5/8 times 7/9. This is 3/8 times 2/9. And the final one is 3/8 times 7/9. They're all over 72. So we can leave them over 72 and just work out the top of the fraction. So 35 plus 6 is 41. Then plus another 21 is 62. And the bottom number is still 72. So as a final answer, we're going to have 62 over 72, which, if you wanted to, will simplify, of course. If you want to, you can half both numbers to arrive at a total of 31 over 36. But with probability, you don't need to worry about simplifying fractions, so 62 out of 72 will do. Or if you want to simplify it like this, 31 over 36, you absolutely can. Either or is absolutely fine. Question 13, we have y being directly proportional to x. So the first thing here, if we have two variables in direct proportion, we can say that one directly proportional, the symbol for proportion is this fish-looking symbol like an alpha, then x. So that's our starting point. Y is directly proportional to x. We then take this and say, if this is true, then y will equal some constant number, let's call it k, multiplied by x. We then substitute in the values we know. So we know two actual values. We know when y is 24, x happens to be 1.5. So if we substitute these values in, we can work out the value of k we're working with. So when y is 24, so I'm going to sub y 24, that's going to be the same as k multiplied by 1.5. Now, being as this is a non-calculator paper, I'm going to give you a couple of ways of making this calculation simpler. My suggestion to get rid of the decimals would be to double the 1.5. And if I double this side, I'm going to double the other side. So if I double 24, I'll get 48. If I double 1.5, I get 3. So k times 1.5 all doubled becomes 3k. Therefore, to get k on its own, I can divide both sides of this equation by 3. So k will be 48 divided by 3, which I'm hoping you'll find is actually 16. So therefore, y equals k, which is 16 multiplied by x. So y is 16 times x. The final step, we have to work out the value of y when x is 5. So when x is 5, y must be 16 multiplied by that value of x, which happens to be 5. 16 multiplied by 5 is 80. So when y is 5, y must be 80 to make that work. Question 14, write 1 over 16 in the form 4 to the power n, where n is an integer. So 16 is 4 squared. So 1 over 16 is the same as 1 over 4 squared. And if we have 1 over a value to a positive power, that's the same as this same value. If it's 1 over, of course, with this power being made negative. So that's minus 2. So therefore, 1 over 16 is the same as 4 to the power minus 2. I can show you a fairly quick way of realizing this. If we just use powers, 4 squared is 16, 4 to the 1 is 4, and 4 to the 0 is 1. If you carry on this pattern into the minus powers, each time we're dividing by 4. So if I go 2, 1, 0, the next one will be minus 1, and the next one in this power series will be this previous value divided by 4. So 4 to the minus 1 will be a quarter, and then 4 to the minus 2 will be a quarter divided by a quarter, which is 16. So this is a way of thinking about it to make it make sense to you. Essentially, the only thing that really matters is the solution that 4 to the minus 2 is 1 over 16. So therefore, as a single power of 4, we need 4 to the power minus 2. This part B here, work out the value of 8 to the 5/3 minus 9 to the power 3 over 2. So let's just write this out slightly bigger. Now, I would always say the bottom number works as the root and the top number works as a power. I'd use flower power here. So start with the roots in the same way that flowers start from growing from the root. The top number is the flower which comes last. The flower is the power. So take the roots first. So with 8, the bottom numbers are 3. That means the cube root of 8. So what we need to do here, first of all, is a cube root of 8. But we could do the power 5 after. The same way, the power of 9 is a cubed, but the root is a 2. So that means the square root of 9, and then after, we're going to cube it. So that's what it actually means in a simpler way. So the cube root of 8 means what number multiplied by itself makes 8? Well, 2 times 2 times 2 is 8. So the cube root of 8 is 2. So that's 2 to the power 5. And the square root of 9 is 3. So that means 3 to the power cubed. 2 to the power 5 means 2 times 2, which is 4. Times 2 again is 8. Double that again is 16. And finally double that is 32. Then 3 to the power 3. 3 times 3 is 9. Multiplied by 3 again is 27. So that becomes 27. And finally, 32 minus 27 gives us 5. Therefore, 8 to the power 5/3 minus 9 to the power 3 over 2 is simplified to just be 5. Question 15, we have an equation of line L1, which is y equals 2x minus 5, and then equation of line 2, L2, is 6y plus kx minus 12 equals 0. So this line L1 is in the form y equals mx plus c. So that's the best form of a straight line, especially for GCSE, sometimes even A-level. So because it's in the form y equals mx plus c, the number in front of the x, in this case the 2, which I'm going to highlight, that tells us the gradient. So therefore the gradient of line L1, gradient has the letter m, gradient of line L1 is 2. Now this second line, L2, isn't in the right format, but I'm going to come to that in just a moment. We can sort that out. The next thing is we have that L1 is perpendicular to L2. So we need to remember if two lines, two straight lines, are perpendicular to one another, then the gradient of one is the negative reciprocal of the other. So if the gradient of L1 is 2 and L2 is perpendicular to L1, then the gradient of L2 will be the negative reciprocal of 2. So we just put 2 as a fraction with 2 on the bottom, 1/2, and switch its sign. The negative reciprocal of 2 is minus 1/2. Therefore, the gradient of line L2 needs to be equal to minus 1/2. So now we know that, we can sort out finding out the value of k. So L2, if I just copy it down here, we've got 6y plus kx minus 12 equals 0. So what I need to have really is just it in the form y equals. I need to make y the subject. So I can subtract kx on both sides and then add 12 to both sides. I need to do the same over here, of course. Minus for kx and plus for 12. And then get that 6y equals minus kx plus 12. Therefore, if I divide both sides by 6, I'll get that y equals minus k. I'm going to write b over 6, just for the k actually, for now. Then 12 divided by 6, because I need to divide everything by the 6, gives us 2. So the gradient of L2, which needs to be minus 1/2, but now this is in the form y equals mx plus c, the stuff in front of the x is the gradient. So in terms of k, the gradient of L2 is minus k over 6. So from both these bits here, we can conclude from that and from this bit that therefore minus k over 6 must be the same as minus 1/2. So if I multiply both sides by 6, to get rid of that fraction, and then get the minus k, is minus a half multiplied by 6. So minus a half times 6 is going to be minus 3. If minus k equals minus 3, you can either multiply both sides by minus 1 or add k to both sides and add 3 to both sides, either or. We see that k must equal 3, and that's the value of k found. Question 16, we have a sphere, and we're told the formula for the surface area of a sphere, which is nice. We're also told next that 3/8 of the surface area of the sphere is 75 pi cm squared. We need to find the diameter of it, given our answer in the form a root b, where a is an integer and b is a prime number. So let's just take this piece of information here about 3/8 of the surface area being 75 pi. So 3/8 is 75 pi. Then we can scale up to find what the full surface area is. So 1/8 of the surface area will be 75 pi divided by 3. So 1/8 of the surface area is 25 pi. Therefore, multiplying both bits by 8, because 8/8 make a full one, we can see that the full surface area is 25 pi times 8, which is 200 pi. We're also told, though, that the surface area of a sphere is 4 pi r squared, and so this 200 pi must be the same as 4 pi r squared. So that's our next step. So 4 pi r squared equals 200 pi. From both sides, we can divide 3 by pi, which then gives us 4r squared equals 200. To isolate r squared, we can now divide both bits of this by 4. And if we do that, we just get r squared on its own. And 200 divided by 4, a quarter of 200 is 50. So therefore, r will be the square root of 50. But we need this, well, we need the diameter actually in a second, in the form a root b. So we need to see if we can simplify this surd. To do that, we try and find the biggest square number we can that's a factor of 50. 25 is a square number, and 25 is a factor of 50. So I can rewrite this 50 as 25 times 2. So if I rewrite this as root 25 root 2, I can then square root of 25. So the radius is therefore 5 root 2. So the diameter, though, because that's what we actually need to figure out, the diameter is always double the radius. So if I take 5 root 2 and double it, that's going to give me 10 lots of root 2. And that, therefore, is our diameter found. Question 17, we need to change the subject. So we need to make x the subject of this formula. That means I need it in the form x on its own equals whatever. So if x is a subject, the subject is never going to be in a fraction. So what we can do here, first of all, we need to get rid of this denominator. Best way of doing that would be to multiply both parts of this by 5x plus 3. So that's our first step. So we'd then get y multiplied by 5x plus 3 equals 4 lots of 2x minus 7. Now, the subject will never be inside brackets, so the next step, we need to expand these brackets. So y times 5x gives us 5xy. Y multiplied by 3 gives 3y. On the other side, 4 times 2x is 8x. 4 times minus 7 is minus 28. Now, if x is a subject, we only need one instance of x. So here we've got two instances. We've got x stuff here and x stuff there. We need to get them all together and then get them all into one group. So I need to get them to the same side of the equation. So what I'm going to do here, I'm going to get rid of this 5xy on the left by subtracting 5xy. But if I do that to the left, I must do the same to the right to keep it balanced. So after this step, I'll have 3y equals 8x minus 5xy minus 28. The goal is to have everything to do with the subject on one side, everything not to do with the subject on the other. So that minus 28 is nothing to do with x, so I need to get rid of it. The opposite of taking away 28 to make it disappear from the right would be to add 28. But of course, what I do to one side, I need to do to the other. So then, I'm going to get 3y plus 28 equals 8x minus 5xy. Now these two instances of x can be made into one by factorising out the x. So if I now write 3y plus 28 and factorise the right hand side, I can take out the x, open brackets. To get 8x, I take x and times it by 8, minus sign, so stick a minus in. To go from x to 5xy, I need to multiply by 5 and y. I can now isolate x by dividing both bits of this equation, both sides, by this bracket 8 minus 5y. So now I'm going to have 3y plus 28 all over 8 minus 5y equals x. But for x to be the subject, x needs to be written first. So I just need to switch this around and put x equals. So x equals 3y plus 28 all over 8 minus 5y. There's another way you could have wrote this as well if you went through this question using a different method. If you factorise differently and rearrange differently, you may have also had, this is an alternative answer, you may have had x equals minus 3y minus 28 all over 5y minus 8. And if you've got this answer as well, this is also valid. So either this solution here or that, both are fine and both will give you full marks in this exam. Question 18, we're doing some shopping apparently. We're going to get some carrots and tomatoes. So 7 kilograms of carrots and 5 kilograms of tomatoes costs a total of 480 pence. That's a lot of carrots and tomatoes. So let's just think about this in a bit more depth. So if 7 kilograms of carrots and 5 kilograms of tomatoes cost 480p, let's just think about what we could call 1 kilogram of carrots. Well, if I just call 1 kilogram, 1 unit of carrots, C, then I can call 7 kilograms 7c. Likewise, if I call a tomato 1 kilogram of tomatoes t, then 5 kilograms I can call 5t. So from this we can make an equation. I'm going to say that 7c plus 5t equals 480. The next line tells us about the ratio of the cost of carrots to tomatoes. So looking at this bit here, the cost of 1 kilogram of carrots to the cost of 1 kilogram of tomatoes is 5.9. So that's the same as telling us that quite clearly the tomatoes are more expensive because the tomato number is a bigger number than the cost number for carrots. So let's just think about this in a bit more depth. 5 to 9 is a slightly awkward ratio. So if I just take this to one side, carrots to tomatoes 5 to 9, and what we could do here is find relative cost of tomatoes for just compared to 1 kilogram of carrots. So if I would set out the carrots and divide by 5, and therefore divide the 9 by 5, I can get this into a ratio of 1.n. So 5 divided by 5 is 1, and 9 divided by 5 would give 1.8. So the ratio of cost of carrots to tomatoes is 1.8. So in plain English, the tomatoes are more expensive than the carrots by how much? Well, they're 1.8 times as expensive as a carrot, because this number is 1.8 times bigger than 1. So putting this into equation speak, if tomatoes are 1.8 times as expensive as carrots, then we could say that T equals 1.8C. In other words, 1 kilogram of tomatoes is 1.8 times the cost of 1 kilogram of carrots. So we can now sub this in and work out what c will be. So I now know that I can rewrite t as 1.8c. So if I just sub this in here and replace t in terms of c, then I've got 7c plus 5 lots of 1.8c, because t is 1.8c, that needs to equal 480. So 5 multiplied by 1.8, 5 times 1.8 will give 9. So we can have 7c plus 9c equals 480. 7 plus 9 is 16, so 7c plus 9c is 16c. That equals 480. Therefore, if I divide both sides of this by 16, I can work out the cost of 1 kilogram of carrots. So cost of 1 kilogram of carrots will be 480 divided by 16. So before we do this division, let's see if we can simplify it. Well, both numbers are even, so we can half both. Half of 480 is 240. Half of 16 is 8. We can half again. That gives me 120 over 4. And keep going until you can see what it's going to be. I think this is easy enough to compute now. 120 divided by 4 is just a quarter of 120, which of course is 30. So therefore the cost of 1 kilogram of carrots is going to be 30p. And because tomatoes are 1.8 times as expensive, then the cost of tomatoes will be 1.8 multiplied by that cost of carrots, which is 30. So 1.8 times 30, I'd suggest we do 1.8 times 3 first. 1.8 times 3 will be 5.4. Therefore, times by 30, multiplied by an extra 10, would give 54. So therefore, cost of 1 kilogram of tomatoes is 54p. So our values, 30 pence for the carrots, 54 pence for the tomatoes. Question 19. In a restaurant, we have a menu which has got starters, mains, and desserts. So there's 5 starters, 12 mains, and X desserts. We're told that there's 420 ways to choose 1 starter, 1 main, and 1 dessert. Find the value of X. Well, the total combinations will be the total number of starters, multiply the total of mains you could match the starter with, and then multiply that by the number of desserts you've got to choose from. So 5 times 12 times x must equal 420. So from this now, we've got a fairly simple equation to solve. So 5 times 12 is 60. 60 times x, I can just write 60x. So 60x is 420. Therefore, if I divide both sides of this equation by 60, I can see that x is going to be 420 over 60. Can cancel the zeros. 42 divided by 6 is 7. So therefore x is 7. In other words, there must have been 7 desserts to choose from. Question 20. For x being bigger than or equal to 0, we have functions f and g such that f of x is 3x plus 4 and g of x is root x plus 2 all over 5. So first we're asked to solve g minus 1 of x. So my suggestion here is I'm going to say let g of x call that y. Just makes it easier later on. So call g of x y. So then we can write what g of x is and then rearrange it to make x the subject. So let's say y equals root x plus 2 all over 5. So to make x a subject, I need to multiply both sides of this by 5. That then gives us 5y equals root x plus 2. To get x on its own, well, root x on its own, I can subtract 2 from both sides next. That gives us that 5y minus 2 equals root x. Then to get x on its own, I need to square both sides. So then I get 5y minus 2, all of that squared, equals x. So write x first. X equals 5y minus 2, all squared. Now we just do a little switch with the letters. So actually, g minus 1 of x, we just call this x now. So therefore g minus 1 of x, then replace the letter y with the same as the input, in this case x. So g minus 1 of x is 5x minus 2 all squared. So that's our answer for part A, 5x minus 2 all squared. Part B, we need to solve this composite function, solve g of f of x equals 3. So we can see that g of whatever the input is the square root of the input. The standard input, of course, is x plus 2 all over 5. But if our input now is f of x, then instead of just having an x as an input, it's going to be 3x plus 4. So g of f of x is the same as not the square root of x plus 2, but the square root of f of x, then plus 2. So f of x is 3x plus 4. So instead of just having an x here, we put 3x plus 4. In other words, that's f of x. So then plus 2 all over 5, that equals 3. So our task now is to solve this equation. So first step, we can multiply both sides by 5 to get rid of the fraction. That then gives us that we've got the square root of 3x plus 4 plus 2 equals 3 times 5, which is 15. I can now take away 2 from both sides to isolate this square root. That then gives us that the square root of 3x plus 4 equals 15, take away 2, which is 13. Now to get rid of a square root, I can square both sides. So if I square the square root of 3x plus 4, I'll just get 3x plus 4 back. And then 13 times 13, 13 squared, is 169. To isolate x, first of all I can take away 4 from both sides. That gives us that 3x is 169 minus 4, which is 165. Finally, divide by 3 to find what just 1x is, and then we're done. So therefore x is going to be 165 divided by 3. And you should find that gives you 55. So therefore x equals 55. Question 21, we have a circle theorem question. So let's just pick this apart step by step. A, B and D are points on a circle with centre 0. So A, B and D are on the circumference. CDE is a tangent to the circle at D. We need to work out the size of angle ADC. And we need to write down any circle theorems we use. So angle ADC first of all. That means the angle is you go from A down to D across to C. So the angle we're wanting to find is this yellow one here, which I'm going to highlight on. That's ADC. CDE is a tangent to the circle. So this line here is a tangent. And this is going to be a clue in terms of what circle theorem to use. We've got a tangent there. If you notice there, D to O is also a radius, which I'm going to highlight in blue. So a tangent meets a radius at 90 degrees. So this angle here, ODE, is going to be 90. And we've used a circle theorem to deduce that, so we need to write it down. So we need to say, ideally, something like this, angle ODE, this one here is 90 degrees, and the circle theorem we've used is that the tangent meets a radius at a 90-degree angle. Next, we can think about what angle BAD is. So if you notice, if I just do a dotted line from B to D, from B to D in this curved bit of the circumference, this arc, that's a tiny chord, and this whole circle almost at the top is the major chord. The way I think about this circle theorem is if you've got an angle at the centre, coming from the same chord, and then an angle at the circumference coming off the same chord, then the angle at the centre is double the angle at the circumference. So because both angle O at BOD and angle A, BAD, originate from this same base, BD, this one here will be half of 64. Half of 64 is 32, and we used a circle theorem to work that one out. So the next line of working should be something like this. Say angle BAD is 32 degrees, quote the circle theorem, angle at the centre is double the angle at the circumference. Alternatively, you could have said the angle at the circumference is half the angle at the centre. It's equivalent to this. So actually we're nearly done now. We could do with working out this angle here, so we can work out the missing angle ODA there. So over here, 32 plus 51 is going to be a total of 83. So this angle over here, because angles in a triangle add up to 180, I can work out by doing 180 minus 83. So 180 minus 83 gives 97 degrees. And so this angle here is 97. And because this one here is vertically opposite, this angle will be 97 degrees as well. So for this triangle here, OD, and this point there, I can work out angle ODA, using the fact that angles inside a triangle add up to 180 degrees. So 64 plus 97, that'll give us a total, if you want to work it out, of 161. So therefore ODA, this one here, will be 180 subtract 161, which is 19 degrees. So angle ODA is 19 degrees. You can put if you want to, because angles inside a triangle add up to 180, but the only thing we need to write down is the circle theorems, so we don't need to go into detail and explain why we know that. But I'll label this on the diagram anyway, so the examiner can see that we know what we're doing. And now we're almost home and dry. So CDE is a straight line. You need to remember that angles on a straight line add up to 180 degrees. So 90 plus 19 plus the angle we're wanting to find must add up to 180 degrees. So the next thing, 90, this one, plus 19 plus ADC must add up to 180 degrees. So from here we can work out what ADC is by doing 180 minus 90 minus 19. So ADC, 180 minus 90 minus 19, that gives us that ADC is 71 degrees. That's our answer, and therefore the question's done. Question 22. We have a cuboid, A, B, C, D, E, F, G, H, as shown, and we're told some measurements about this cuboid. So we're told that AF is 6.8 centimetres, so let's just highlight this and add this on. So from A to F is 6.8, and from F to C, from one corner to the opposite down there, is 13.6. So if I highlight this in blue, we're going to form a triangle in a second. So before that though, we need to work out the size of the angle between FC and the plane ABCD. Let's focus about what this means first. So the plane ABCD, a plane is just a mathematical word for a 2D area, like a 2D surface or section of a surface. So ABCD, the plane ABCD just means the flat surface, in other words the base of this cuboid. So if I just highlight this in yellow, then what we're wanting is the angle in between this blue line and the yellow base. So if I just sketch on a diagonal here from the blue down to the base of a red line like so, we can find the angle FCA. So basically that's going to be the angle in between FC and ABCD. So if I add this on here and call it X, that's the angle I'm trying to find. That's the angle in between the yellow and the line FC. So this is 3D and looks slightly more complicated, so I'm just going to do a 2D version over here, just so it's a bit clearer. So now we can think of this using standard trigonometry in just 1 second. So because it's going to be a standard trig question, it's going to be a case of SOHCAHTOA, and because this is a non-calculator paper, what this is going to involve in a moment is use of exact trig ratios. So first of all though, let's just think about SOHCAHTOA, like so, and let's label in the sides we know. So relative to the angle we're wanting to find, x, then 6.8 is opposite to that, so that's our opposite angle, sorry, opposite side rather. This is the right angle. Opposite the right angle is always the hypotenuse, the longest side. So I know O, and therefore I know H. So now, in terms of if it's going to be SOHCAH or TOA, I pick the triangle which includes both sides I know. So the only one that includes O and H is the SOH triangle. So to find an angle, we cover up S for sin, C for cos, T for tan, depending on which one we're picking. Because we're picking SOH, we cover up the S. Therefore, the angle x will be sine minus 1 opposite divided by hypotenuse. Or we can put it a different way and just say simply that sine of x is the opposite, which is 6.8, divided by the opposite, which is, sorry, divided by the hypotenuse rather, which is 13.6. But what we need to notice here is that half of 13.6 is 6.8. So actually this fraction is the same as 1/2. And this is our key insight. Sine x being a half, 1/2 is one of these special trig values. So I'm going to remind you what they all are here. So if we have sine being equal to a half, sine of an angle is a half, that is the same as saying that the angle therefore must be 30 degrees. So from this, as long as we remember our exact trig values, we can therefore deduce that the angle x must be 30 degrees. Because when x is 30, that gives the exact trig value of sine of 30 being a half, which is what it is, because we had 6.8 divided by 13.6. The sine of this one is a half. Therefore, it's got to be a 30-degree angle. Question 23. We need to write this horrible-looking pair of fractions in this form here, where a, b, and c are integers. Integers in this case just means, well, in any case, just means whole numbers that are allowed to be negative. So if I just take this piece by piece and focus on this one first, what we need to do here is to get rid of any roots, because our target is to have it as a whole number. So what we need to do here is rationalise the denominator. So if I just take this part of it here, to rationalise this, I multiply both top and bottom by this bit here, but with its sign switched. So I multiply both top and bottom by 4 plus root 3. So if I look at the bottom of this, I'm going to have 4 minus root 3 multiplied by 4 plus root 3. This is essentially the difference of 2 squares. So I'm going to have 4 squared, which is 16, minus root 3 times root 3. Root 3 times itself gives us just 3, so that's going to be 16 minus 3 on the bottom. And on the top, we're going to have 3 root 3 multiplied by 4 plus root 3. So obviously the bottom is just going to become 13. And the top, if we expand it out using the grid method or otherwise, I'd get 3 root 3 multiplied by 4, which gives 12 lots of root 3. And then 3 times root 3 multiplied by another root 3. Well, this root 3 times this root 3 will give 3, multiplied by the normal 3 that we had anyway. 3 times 3 will be 9. So I'm going to do plus 9. So that's the first bit done. So we now know that this can be written like so. We now need to focus on the 2 root 3 part as well. So what we need to do there is to rationalise that denominator. So 2 over root 3. I can get rid of that root 3 by multiplying both top and bottom by the square root of 3. On the bottom, root 3 times root 3 will just give us 3. On the top, 2 times root 3, of course, is just literally 2 root 3. So now if we piece these together, and then we can aim for a common denominator, we're going to be done. So that bit and that bit gives us that we're going to have now, this here is the same as 12 root 3 plus 9 over 13 plus 2 root 3 over 3. This needs to be combined into a single fraction, so I need these to have a common denominator. So what I can do here is multiply each denominator by its opposite counterpart. So if I do 13 times 3, that becomes 39. I then need to do the same to the top. Likewise, if I multiply the bottom of this by 13, that'll become 39, hence giving us a common fraction denominator of 39. Therefore, I need to do the same to this top here. So then, 12 root 3 times 3 becomes 36 root 3. 9 times 3 is 27. And then over here, oops, almost made a mistake, that should be a minus. So if I just take that to a minus, my bad, there's a minus sign there. So then I need to do 2 root 3 times 13, which is 26 root 3. So it's going to be minus 26 root 3 here. Then 3 times 13, again, is 39. So I can put it all over 39. Finally, neaten it up slightly. I've got 36 root 3 here, but I need to take away 26 of them over here. So 36 take away 26 is 10. Therefore, 36 root 3's take away 26 root 3's gives 10 root 3. Of course, we've got that plus 27 as well, all over 39. So that's our fully rationalised fraction. And not that you need to say A is 10, B is 27, and C would be 39. Finally, question 24, the last one on the entire paper. So we need to find the set of possible values of x for which 4x squared minus 25 is less than 0, and, simultaneously, 12 minus 5x minus 3x squared is bigger than 0, showing all working, of course. So let's just take this step by step. So first I'll have this one in here, which I'm going to highlight in blue. 4x squared minus 25 less than 0. Now this isn't too problematic. I'll explain what to do with this in a second. The main bit here is difference of two squares, so good job if you've spotted that straight away. This one here, though, is looking a bit more nightmarish, because we've got a coefficient of x squared which is more than 1, and it's negative as well. Now, although you could technically multiply both sides of this inequality by -1 to get it into a positive 3x squared, I tend to suggest to students to avoid multiplying or dividing by negative values with inequalities, because to do that successfully you need to flip this inequality symbol over, which sometimes students forget. So my suggestion would be to avoid that and rearrange this by making the left-hand side equal to 0 and transferring all of these terms here, therefore, to the right-hand side. So what we can do here, we can get rid of this 12 on the left by subtracting 12, the minus 5x, we can add that 5x, and likewise this minus 3x squared, we can plus 3x squared. So if I do these bits to the left-hand side, I need to do the same to the right-hand side. So the right-hand side of this will become positive 3x squared plus 5x minus 12. So from here, we can rearrange into this form, and then if I just switch the order and put the 3x squared plus 5x minus 12 first, we can hopefully clearly see that we need 3x squared plus 5x minus 12 to be smaller than 0. So this bottom bit here is equivalent to what we had at the top, but this will be much easier to work with. Now, to picture the set of values we need to find, I'm going to suggest two things. I'm going to suggest we do both. Both plot them on a grid, well, sketch them, I should say, and then also consider what the inequality solutions would look like on a number line. So I'm just going to get a x and y grid up here to sketch on. And now we can think about solving these individually. So first of all, 4x squared minus 25 less than 0. Well, the square root of 4x squared is 2x. The square root of 25 is 5. So this one we can write as 2x plus 5, 2x minus 5 less than 0. Now the critical values of this, basically the values of x which would make this equal to 0, would be when each bracket is made equal to 0 itself. So for this first bracket, x, what would x need to be to make the bracket equal to 0? Well, essentially I'd set 2x plus 5 equal to 0, and then solve that equation. Same here. So 2x plus 5 equal to 0, or this one, 2x minus 5, may be equal to 0 as well. So if this is the case, x would have to be minus 5 over 2, subtract 5 by both sides, then half. Or for this one, add 5, then divide by 2. The solutions to that are x is positive 5 over 2. So now if I imagine a graph of this one, a sketch of it on this grid, they're my critical values. Now because I'm wanting this to be less than 0, what I'm wanting here is actually this region of the graph, the underneath part. So solving this one, in terms of inequality, I need x to be more than minus 5 over 2, or I can call it minus 2.5 if I want to, but no more than 5 over 2. So represent this on a number grid, sorry, on a inequality line. Going to look like this. So in between minus 2.5 and positive 2.5. Similarly now, I can solve this one in red by factorising. Now, how you want to factorise this is up to you. The method I use isn't always used by other teachers. It's a bit of a hacky method, a bit spawny. That's using, I don't know, gamer speak, trying to be cool and failing miserably, no doubt. This one here, I'm going to factorise it using this little sort of trick I use. Now, it doesn't matter if you use a different method, but hopefully you'll agree with the final result. So what I can do here, I can shove this 3 to the minus 12 at the end and multiply them, then forget this 3 was ever there to begin with. So I'm going to think of this now as just factorising x squared plus 5x minus 36, and factorise that as a bog standard simpler quadratic. So I need two numbers that multiply to give me negative 36 but add up to 5. Those two numbers, hopefully you can see, would be positive 9 and minus 4. Of course that 3, we forgot about it and made it disappear. We put it back in now underneath each number in these brackets. So I write 9 over 3 and 4 over 3. Now if I can simplify a fraction, I do that. So 9 over 3, obviously I can simplify to just simply 3. 4 over 3 doesn't simplify, and if I still have a denominator left, which I do, I still have this 3, I shove that 3 to the front of the x, so it becomes 3x minus 4. So actually I need that to be less than 0. Then the same way as before, to find the critical values, I see what x would have to be in each bracket to make each bracket in turn equal to 0. So this first one here, I'd need x to be equal to minus 3, or for this one, on the right hand side, I need x to be equal to 4/3. So therefore for this one, the inequality solution in red would be I need x to be more than minus 3, but less than 4/3. So if I now add this onto this number line here, like so, that's the one I need in red. And likewise in the graph, that's what I have here. So for this one, I need it to actually be below the curve, because it needs to be less than 0, 2. So I'm wanting that part there. So when, because I need this to be less than 0 in blue, and this one in red to be less than 0, where are they both less than 0? For example, when x is minus 2.9, the red would be less than 0, but the blue wouldn't. Or likewise, over here, if x were 2, the blue would be less than 0, but then the red wouldn't. So in between which two values are we needing? At this point, I think it's useful to use the number line to find the two values we need. So reading this top down, we need it where both red and blue exist, where it's not just red or not just blue. So we need it in this region here, where both are solved. So we're after in between minus 2.5 and all the way up to 4/3, which is where the red one goes above 0, even though the blue one isn't there yet. So where they're both satisfying being less than 0 is in between -2.5 and 4/3, and that therefore is our solution. So therefore, we need to write down that x needs to be more than -2.5, or -5/2 if you want to use a fraction, all the way up to, but not including, this bit here, which is 4/3. And that's the last question sorted. Whoops, made a mess of that one. That's the last question done, therefore the whole paper has been complete. So I hope you found that useful to some extent. As ever, some questions are absolutely horrible. That's the nature of the higher tier GCSE maths. Thank you very much for listening to that, and please do tune in again for the next video. Take care of yourselves, and I'll see you all very soon.